first thing we're going to do when we have a word problem like this, we're going to identify the givens and unknowns, right? So what's something given? What's this?
That's the speed of the bus. VBC.
VBC. It's the velocity of the bus relative to the ground, right?
Wait, why is it not AB?
Because AB is
The aardvark.
aardvark relative to.
Boom.
What's 12 meters per second at 72 degrees?
The bus, the aardvark to the ground.
AB.
Makes it AC.
AC. It's aardvark relative to the ground, so it's AC. Right? And what are we looking for? We're looking for the velocity of the aardvark relative to the bus. So that's AB. Right? Now, do we have a relationship?
Yes.
Of course we do.
You bet we do. VAB, when added as a vector to VBC, will give me VAC. Is it arranged such that what is unknown is isolated?
Yes.
No. What are we after?
Sorry. After AB.
We're after AB. Is AB by itself? No, so we have to...
Subtract BC.
Yes, we have to subtract BC from both sides. So we get AC minus BC. Yes. Now, can we have a little parenthetical moment? Let's pause for a second and look at this. If that's vector A, and that's vector B. If I told you to take vector A and add it to vector B, what would you do? Yeah, just put A, tail to tip, with B, right? Like this. And I would get that vector A plus that vector B. Easy enough, right?
Yeah.
What if I told you to take vector A and subtract vector B?
Why?
Then you just leave A. No, you know.
You have to get the opposite direction.
I have to go the opposite direction. That negative sign means flip the direction of the vector. Add the opposite direction vector. So how do I do that? I turn around and come back to the left.
We need to find this.
Wait, how do you know if it's going back?
It's on 360.
Oh, well, over here, I see both of these are going to the right. And so the negative would be going to the left. Okay?
70.
Now, translate that up to here. What does that mean we're going to do? We're going to do AC, which is what? 12 meters per second at 72 degrees. And then what?
Attach it to 7 meters per second.
And I'm going to add it to 7 meters per second.
South. Down.
So it's going to go up.
Yes. I'm going to add 7 meters per second north. Why? Because this negative sign says flip BC. Add the opposite direction. So instead of 7 meters per second south, it would have come down south, but instead I'm going to make it 7 meters per second north.
What?
It's not a triangle though.
Wait.
Gosh.
Okay.
Just wait.
Important question.
First of all, don't worry if you don't see the triangle yet. Were the what's because I went north, or the what's because you didn't expect the shape?
Both.
Both.
Because that's a problem. Because here's why we went north. Pay attention. We just went through this. We said that the negative sign means we flip this vector. We add the opposite direction vector. It would have been 7 meters per second south, but since it's flipped, we make it 7 meters per second north. Okay? Now you can, what about the shape?
What?
Okay.
So it has been 12 meters per second.
time you have to switch it.
Every time it has a negative sign in front of it. Right? Before we didn't have any negatives because it was already arranged the way we wanted it. Now that we're looking for somebody who originally was on the left side of the equation, we had to move somebody over to the right, and that caused them to be negative, which means we have to flip it back. Yes?
How'd you know to do, the 12 meters per second first?
Because it's right here. Hey, listen. First of all, does it matter which order I add vectors?
Yes.
No. I can add vectors in any order I want. Remember that F3M where I said your friend says going this way, this way, this way, this way is the same as going this? Remember that?
Yes.
One of the properties of vectors is it doesn't matter what order you add them in. If you don't change direction, you get the same sum. So I could do the negative BC plot first and then add the AC. It would be the same thing. But I'm choosing to go with AC first because it was first in the equation and it's not the one I have to flip around. Okay?
It wasn't the first one.
And it is now.
It is once I get it arranged for what I'm solving for it is. Okay? Okay? Now, here's where it's like those displacement problems where it's a little tricky because you don't see the triangle at first.
Oh, just like the birthday problem.
What do I want? Yes, it's like
Place it from your original to the top.
good. And AB is from where I started to where I ended up. Right there.
Oh.
And you see that it's the hypotenuse of a triangle? One that goes this way and that
So
way.
you're going to do 90 minus 72 to get the angle down there, right?
Well, here's what I'm going to do.
It's other.
I'm going to take this vector first. Remember that? Hey, guys, focus. Remember that chapter 3 homework assignment where you took a vector and you broke it down into its components?
Right.
This guy right here is going to the right and he's going up. Can I find out how much of him is going to the right and how much of him is going up? Yes, because I know the hypotenuse is 12, I know this angle is 72. Can I use some trig to find the two legs of the triangle? Yes. So cosine of 72 times 12 is what? 3.7? And sine of 72, because I'm doing the opposite side, times 12 is 11.4. Now, let's look at the green triangle, because that's what we're really interested in, right? What's the the horizontal component of this green triangle?
3.7. And then the other is going to be
Good, it's 3.7. And what's the vertical component? 18.4. Salud over there. Now, do we have enough to be able to find the resultant?
C. Probably.
Yes, we p-back it, right? 18.4 squared plus 3.7 squared, and then take the root of that sum. Which is what? Somebody there yet? I agree. 18.8 meters per second is VAB.
What? What is the direction?
But what is the direction?
Just find it. Just find it, man.
I tan this guy, right?
Yeah.
Tan of 3.7 over 18.4, or inverse tan. I'm getting 11.4 degrees. Do you agree? So how do I get that out of 360? Which quadrant is it in? First quadrant, so I subtract from 90. So 90 minus 11.4.
Wait, you could have gotten the same
At 78.
thing by doing
Or 78.
blah, 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 blah. 12 plus 7, can you?
No. No, 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 no.
No.
Because doing 12 point plus 7 is just adding scalars.
What is that?
But I gotta add vectors.
You were close.
Well, and that's the thing, right? If that's a real steep angle, the answer ends up rounding to the same, but it's definitely not the same. And if I change the numbers up, it'll be more. Yes, Claire.
I have a question to make, just make everything really confusing. You see that triangle in the middle? Could
Yes.
could you just use the law of cosines or law of sines to find out that side?
Could I use this triangle here?
Yeah.
You better believe I could.
You don't know any.
I could use law of sines,
Yeah,
law
you
of
can use law of
cosines.
sines or law of
I don't
cosines.
remember. I
Absolutely.
definitely tried that.
And of course, law of sines is easier, right? But yes, you can always use law of sines, law of cosines, but if you don't remember them, you can always get around it and not use law of sines, law of cosines by finding the right
All you
triangle.
needed is something